Welcome to the OpenTelemetry Cost Savings Checklist webinar presented by Integration Plumbers. I'm Jesse Raleigh, Head of Engineering, and today we're going to review some of the strategies to maximize the ROI from your OTEL deployment. The team at Integration Plumbers has been in the monitoring and telemetry business for a very long time, developing custom integrations and supporting enterprise partners such as Oracle along the way. Our leadership team have been founders or co-founders of several industry-leading companies in both the OTEL and broader telemetry markets. From racks of servers and data centers, fleets of VMware virtual machines, to industrial control systems, our team has been collecting, storing, and processing critical data flows for decades. Our expertise and breadth of industry knowledge can help you manage the costs and complexity inherent with enterprise-scale OpenTelemetry deployments. Whether you need a full strategy and implementation support or are trying to trim the fat from an existing deployment, we'd love to help. In this webinar, we're going to explore some costly pitfalls with OpenTelemetry deployments while considering ways to address them within the context of a hypothetical customer. Our scenario is going to be built around an automotive parts retailer, SparkPlug Motors. They have a fairly common e-commerce stack using Rails, Postgres, Redis, and Elasticsearch. Initially, they had used external services, such as New Relic, but found that the costs and limitations left them feeling like their needs were never fully satisfied. To address this, they decided to migrate to an in-house OpenTelemetry deployment. The SparkPlug Motors e-commerce stack is a case study in boring technologies. The core pillar is a Ruby on Rails-based e-commerce store. For our purposes, we're going to consider the services that support this directly, as well as our telemetry and monitoring services, as internal. Large files, such as service manuals, parts PDFs, or installation guides, are stored in S3 buckets. Inventory levels are aggregated from half a dozen manufacturing facilities owned by SparkPlug Motors. All these divisions are running a variety of AS400-based ERP systems, which incorporate into our deployment using IBM-powered Data Gateway. These services, along with payment, merchant services, and gateways, are considered external because they exist outside of the network environment of our core system. External systems introduce additional latency as well as the potential for collection disruption. Consideration should be given to the buffering and caching needs for external systems on a case-by-case basis. Even prior to introducing OpenTelemetry, SparkPlug Motors had a lot of moving parts. They managed their own small-scale data center at their corporate headquarters, and each of their manufacturing facilities has a server room housing an AS400 and other back-office IT servers. The e-commerce platform is hosted in the cloud, with test and development servers running in the data center at the central office. Incoming orders were typically fulfilled through multiple divisions, making the overall health of the entire network important for the storefront. OpenTelemetry collection servers and long-term storage solutions were housed at the central office where most of the IT support and reporting needs existed. This allowed them to bring all of their disparate data sources into one cohesive system for alerting, analytics, and reporting. Previously, it was a challenge to attain a broad view because boundaries existed between their modern systems and the legacy ERP systems throughout their network. OpenTelemetry supports automatic instrumentation in a number of languages, providing a near turnkey solution for many instrumentation targets. Using language-based auto-instrumentation and adding manual spans at the next upstream step reduces development time and overall complexity. The SparkPlug Motors team used the OpenTelemetry SDK and the OpenTelemetry Instrumentation All Ruby gems in their e-commerce application. By creating an initializer in their project, they were able to add instrumentation throughout the application without further changes to their code base. Manual instrumentation is powerful but expensive to develop and maintain, so the SparkPlug Motors engineering team only introduced them when it was essential. Complexity is expensive and to some extent unavoidable. Pushing as much parsing and processing logic as possible to your collectors not only reduces the overhead on your applications, it also simplifies future updates to collection parameters. Utilizing a transform processor, incoming metrics can be processed and enriched or distilled before being passed along upstream. Processes can be chained together in ways that either enrich or condense and distill your data, until it is ultimately sent through an exporter into your chosen observability backends, such as Prometheus or Jaeger. The OpenTelemetry protocol is a general-purpose telemetry data delivery protocol describing the encoding, transport, and delivery mechanisms of telemetry data between telemetry sources, intermediate nodes such as collectors, and telemetry backends. To the extent possible, your applications and services should leverage the OpenTelemetry protocol. This way, changing vendors, endpoints, or sampling is a configuration change, not a code change. One of the biggest advantages to using OTLP is that it is powered by protocol buffers under the hood. Protocol buffers are Google's language-neutral, platform-neutral, extensible mechanism for serializing structured data. Think XML, but smaller, faster, and simpler. You define how you want your data to be structured once, and then you can use special generated source code to easily write and read your structured data to and from a variety of data streams and using a variety of languages. Unlike JSON or XML, which are text-based, protocol buffers are a binary data interchange format, which is considerably more efficient. Protocol buffers provide significant advantage because they are much more compact data interchange format. Fewer bytes to transfer, parse, process, and store equates to lower total cost overall. Another major advantage of using OTLP is the ability to implement back pressure, which helps prevent overwhelming your data pipelines. SparkPlug Motors didn't face massive traffic volume, but they did suffer from relatively slow connections to some of their manufacturing divisions. The combination of efficient data transfer and being able to intelligently reduce telemetry congestion during busy network operations, such as transferring backups, resulted in SparkPlug Motors getting excellent utilization out of expensive network interconnects. OpenTelemetry defines semantic conventions, sometimes called semantic attributes, that specify common names for different kinds of operations and data. The benefit of using semantic conventions is in following a common naming scheme that can be standardized across the codebase, libraries, and platforms. By using OpenTelemetry semantics wherever possible, rather than creating ad hoc semantics on the fly, you gain the benefit of support from existing visualization and reporting tools. You also stand a higher chance of finding solutions to any issues that you might encounter by virtue of there being more people relying on the same tools you're using. SparkPlug Motors got most of this benefit for free by using auto instrumentation as much as possible, but with some of their legacy systems, they put in extra effort to identify existing data semantics rather than introducing new ones. High cardinality data is characterized by a large number of distinct values within a dataset. In database terms, cardinality refers to the uniqueness of data values in a column. A high cardinality column contains many unique values, while a low cardinality column has few unique values. An example of low cardinality would be order status, such as pending, shipped, or delivered, where many orders will be in one of those statuses. High cardinality would be an example of the order ID itself, in which there's a unique value for every order in the entire system. At SparkPlug Motors, transforming collectors reduced data collection considerably while allowing the sales team to prioritize converting pending sales to closed deals with proactive outreach and client communications. To review, we want to auto-instrument everywhere that it is practical to do so, utilize exceptional instrumentation approaches for exceptional cases or situations, move the complexity out of our application and into the upstream collectors, standardize your semantic conventions, and as much as possible, use the existing definitions. Carefully control the cardinality of your data. A pile of individual Legos versus kits and boxes with pictures to show you what they become. Basically, the difference is signal versus noise. Reducing data overload in OpenTelemetry deployments generally comes down to collecting only what is valuable. SparkPlug Motors stuck to the best practices, pushing, filtering, and sampling as far upstream as possible, using tail-based sampling, metric aggregation, and attribute filtering at the collector to prevent low-value spans, logs, and high cardinality labels from ever reaching their storage systems. Sampling is one of the most effective ways to reduce the costs of observability without losing visibility while maintaining representativeness. Representativeness is the principle that a smaller group can accurately represent a larger group. Representativeness can be mathematically verified, meaning that you can have a high confidence that a small sample of data accurately represents the larger group. For high volume systems, it is quite common for a sampling rate of 1% or lower to very accurately represent the other 99% of the data. SparkPlug Motors applied several sampling rates throughout their deployment, adjusting as needed based upon the volume and data visibility requirements. Head sampling occurs at the earliest creation of a trace. It provides great visibility into the performance of your application, provided your application remains in the happy path. External observation is still essential for capturing failures which cannot be adequately observed from within the application. Since SparkPlug Motors utilized auto instrumentation libraries in their e-commerce application, which uses head sampling by default, much of their data was derived from this sampling method. Rate limiting rules are not limited to throughput alone, but can leverage additional rules and logic in determining what data gets discarded and which gets transferred. SparkPlug Motors utilized OTEL collectors and transformers running on the same hosts as their application, which allowed them to implement buffering and rate limiting during unexpected bursts of activity. Tail-based sampling is the most detailed and most costly type of sampling to utilize. The main benefit of this type of sampling is that decisions on the data can be made with the full knowledge of the entire trace. When implemented carefully, it can help you capture high-value events reliably and have high confidence that discarded data was of low value. SparkPlug Motors utilizes tail-based sampling during their regular telemetry audits to help ensure that their normal sampling strategies aren't missing important insights. Sampling strategies help turn torrential flows of data into manageable trickles of high-value information. They can be mixed and matched to balance the cost and value of the captured data. They should be periodically reviewed to ensure that they're still aligned with the business requirements. Improving the signal-to-noise ratio in an OpenTelemetry deployment lowers costs by reducing the volume of low-value telemetry that must be stored, indexed, and queried. When SparkPlug Motors preserves only meaningful traces, metrics, and logs, the back-end footprint shrinks. Fewer spans flow through the collectors, less data hits long-term storage, queries run faster, and you avoid expensive scaling of ingestion pipelines, indexers, and retention policies. In practice, better SNR means SparkPlug Motors pays only for insights instead of exhaust. SparkPlug Motors employed inversion in considering their instrumentation requirements. While this concept is not specific to the realm of OpenTelemetry, applying these principles can result in significant savings in not only data storage and transfer, but in lost time collecting irrelevant artifacts. SparkPlug Motors identified a series of critical paths in their overall e-commerce and fulfillment systems, ensured that they had visibility on these elements as their priority, and only then began expanding their focus on useful but not essential services. Golden flows, service level objectives, and common failure modes are all primary candidates for being considered signal. SparkPlug Motors might not care about the performance of every request posted to the search endpoint, but they care greatly about the slow searches and any errors that might surface. SparkPlug Motors segmented their metrics into two primary types of data. Red metrics are rate, requests per time interval, errors aligned with the rate, and the duration or latency of requests. Use metrics are utilization, saturation, and errors. Red and use metrics are generally of high value and should be evaluated for retention and enrichment. You might have noticed that errors are included in each type of data. This is because they are generally of high importance, and each type of data measures a different dimension of the system. Including them in the collected data for each category helps ensure that the information will be proximate and correlate when analyzing results. Red metrics are generally user visible, whereas use metrics typically focus their scope to component or resource failures. SparkPlug Motors prioritize their monitoring targets around the types of events that disrupt their business. By applying a priority matrix, they were able to segment their service metrics into 4 categories, handling each according to importance. Urgent and important had a high sampling rate, longer retention policies, and we're likely to have real-time alerting system integrations such as PagerDuty. Not urgent but important, utilize stratified sampling, data enrichment, longer retention policies, and more likely to have prominence on dashboards instead of alerting integrations. Urgent but not important, error logging and short retention policies, email notifications where appropriate. Not urgent and not important data was discarded or heavily aggregated. SparkPlug Motors conducts regular reviews of their metric usage to identify areas for improvement or cost savings. Seek to identify metrics with zero or near zero queries, look for dashboards that haven't been used in months, evaluate alerts that get ignored regularly. For example, SparkPlug Motors has one division in rural Indiana which has a radio-based internet connection and that is regularly unstable. The default alert rules in place for all divisions resulted in alert fatigue among the IT staff, which, left unchecked, could lead to a culture of ignoring alerts. SparkPlug Motors applied a specific rule, increasing the alerting threshold within weeks of deploying their OpenTelemetry system to address this problem, additionally instituting a policy of quarterly reviews of their telemetry data. So, to review, SparkPlug Motors used the process of inversion to help identify and define our critical workflows, prioritized our monitoring around the most impactful services. With the clarity gained, we were able to define what signal means in the context of our deployment, so SparkPlug Motors didn't waste time on unproductive but noisy issues. We learned about read and use metrics and how prioritizing them by importance, not just by percentage of traffic or other naive approaches, helps us avoid collecting and storing irrelevant metrics. We discussed the importance of periodically reviewing your metric consumption so that we can stop paying for collection and storage of data that no one cares about or uses anyway. Now, we're going to cover one of the problems SparkPlug Motors encountered when applying sampling to our collection, which is the introduction of bias. SparkPlug Motors began by applying a single global sampling rate to their e-commerce API, only to discover some unfortunate side effects. High traffic endpoints dominated the sampled data. Low traffic endpoints sometimes disappeared from collection entirely. After some internal deliberation, they settled upon a sampling strategy that would allow them to have high confidence in their data while managing volumes reasonably. SparkPlug Motors first began by using stratified sampling, applying different rules for different types of sample data. This helped to keep sparse but important data visible while allowing them to tune the collected data to align with business objectives. The example strategies that you might employ include segmenting by endpoint, by outcome, or by customer tier. With heavily trafficked endpoints such as search or payment, samples might be collected at a 5% rate, while checkout is at a 50% rate. The utility value of the information to the business will help determine the appropriate sampling rate. Event-based segmentation would generally be employed in conjunction with other segmentation strategies. Error events might be captured 100% of the time, with successful events subject to the additional filtering rules you have in place. With the customer tier example, we can envision having a few classes of users for our e-commerce store. Guests who are not logged in and can't transact but just browse, customers who have created accounts and can transact via credit card, and businesses who are larger scale customers who can transact with purchase orders or higher value transaction methods such as ACH. In this example, we want to prioritize our sampling based on the value of the prospective customer. We know that anyone logged in as a business user is likely to be high value and likely to convert to a sale. We might care more about how their search performance is working, so our sampling rate for this class of customer might be 10% instead of the standard 5% for other user types. This sample output gives you an idea of what to expect to see when you retain the probability and strategy with your traces. In this example, SparkPlug Motors is sampling 10% of the time using the trace ID ratio strategy. The specific trace ID ratio is tied to the parent span, so it will inherit whatever collection ratio of the parent span. SparkPlug Motors doesn't anticipate encountering any load-related data dropping, but they implemented back pressure as much as possible to address problems within their overall network. By using back pressure, you avoid biasing your collection against the very time periods that are most critical to your operations. Back pressure in telemetry is a mechanism that prevents data pipeline from being overwhelmed when data producers generate information faster than data consumers can process it. This creates backup or pressure in the system where buffers fill up and can lead to data loss, memory exhaustion, or crashes if not handled properly. To manage this, the receiving component sends a feedback signal upstream to the producing component to slow down or temporarily pause the data flow. Without establishing some basis of ground truth, conclusively understanding SparkPlug Motors sampling bias becomes impossible. By having a data set to compare against with 100% sampling over a short period of time, we can compare event rates to identify outliers within our reduction strategies. This can be accomplished by a variety of ways, such as sampling a single environment or service for a short period of time, or by sampling the entire system during low traffic periods for a more holistic perspective. If the sampling metrics differ considerably from your full set, you can adjust your sampling strategies accordingly. SparkPlug Motors schedules several calibration sampling runs each year, usually aligned with national holidays when they experience lower than average traffic. The nature of SparkPlug Motors systems doesn't lend itself well to sampling individual environments, so they opt for 100% sampling. To review, use stratified sampling to segment traffic into meaningful groups such as region, customer tier, or environment, so no single noisy segment dominates the data. Record sampling probability and strategy on each trace so that you can correct for bias, compare across strategy changes, and keep analysis grounded in real rates. Avoid load-correlated dropping. When systems are under stress, you need visibility the most. Use back pressure and resource limits, and if you must drop data, do it randomly. Regularly recalibrate with periods of high sampling to re-baseline, detect hidden bias, and tune sampling rates. Done together, these practices make sampling a controlled, predictable component of your observability budget rather than a guessing game. In closing, if you enjoyed today's session, don't let this just live in your notebook. First, if you'd like to talk through your environment, you can contact our team using the link on the slide or by scanning the QR code. Just send a quick note about your stack and where you feel the pain today, cost, noise, missing signal, and we'll follow up. Second, we're happy to set up a workshop or a one-on-one call. This can be as small as a whiteboard session with one architect or a working session with your whole site reliability engineering and platform team. The goal is to map what you have today against this cost optimization checklist and identify realistic wins. Third, if you're ready to get hands-on, we can guide a proof of concept of migration, whether that's moving from legacy agents to OpenTelemetry, consolidating multiple pipelines, or just reducing what you ship into your current backend without losing critical signal. We'll work with your team so that the proof of concept is something you can actually build on, not just a demo that dies a day after the webinar. And finally, if you just want to learn more about our services, use the same contact page. Tell us what you're exploring, and we'll connect you with the right folks on our side. Thank you again for spending time with us today and for caring enough about observability to make it better instead of just bigger. We'd love to keep the conversation going. Have a great rest of your day.